Dear students, how are you all? I guess you are doing well. Well, we are studying a chapter called Chapter 6 Effect of Heat on Matter. Well, in this class, we will discuss about the terms and condition and reflection of this equation which we have discussed yesterday. First, we would like to share with you a simple thing, that the relation between the coefficients, the relation between alpha, beta and gamma. The relation are beta equal to 2 alpha 2 times and gamma is equal to 3 alpha. If we conjugate it all, then we can find, see here, alpha is equal to beta by 2 is equal to gamma by 3. Okay, so now we find out here this. Okay, so as a whole we can write 6 alpha is equal to 3 beta equal to 2 gamma. Okay, now it's a mathematics part, like sort of creative question part. CQ1, the length square 89 degree Celsius its length becomes 100.0 Celsius. First question, what is heat? Second question, write the difference between heat and temperature. C, what would be the normal temperature? Okay, what would be the reading in height scale when the of the rod is in D. What is the coefficient is it possible to find the linear coefficient of the dot? So first, you might answer the A and B question. I am now quite sure of it. Now C. Simple. See here. Given given in Celsius, C is equal to 36.89 degrees Celsius is given. To find finite, F is equal to what? So the equation is something like that: C by 5, F minus 32 by 9. Okay, so if we calculate it, like minus 160 equal to 9 C. So F is equal to 9C plus 160 by 5. So 9 into 36.89 plus 160 by 5. So answer is 98.402 degree Fahrenheit. That's the answer of the question. Okay. Now D. D. Well, here given L1 equal to 10 meter, sorry 100 meter, my mistake, meter. L2 equal to 100.033 meter. Then T1 is equal to 36.89 degrees Celsius, and T2 is equal to 66 degrees Celsius. We know the difference between the temperature between Celsius and Kelvin is kind of same, so we simply can make a difference between 36.89 degrees Celsius. So here comes 36, it is 30 degrees Celsius or equal to 30 Kelvin. So the difference is same. So we can write this simply. So we know del L equal to alpha L1 del T. So L2 minus L1 equal to alpha L1 del T. So alpha is equal to L2 minus L1 del T. So this is 100.033 minus 100 divided by 100 into 30, so prime 1.1 10 to the power minus 5 minus 1. So it's possible to find out the linear coefficient. Okay, CQ2. This is a very important criterion, okay, for establishing railway line at construction firm designed a 100-kilometer railway line on a bridge. They left 1.5 centimeters gap between two consecutive plates of 25 meter long for the possible 16 degrees Celsius increase of temperature. What is resolution? Why does cooking at the top of hill is difficult? Explain. C. Find the coefficient of linear expansion of the set building. Find the coefficient of linear expansion of the set line. The set rail. The if the coefficient of the linear expansion of the real line is sorry, if the increase of temperature is 40 degrees Celsius, will the attain safely explain mathematically. Okay. Now first, what is resolution? The process of turning a solid matter to liquid using pressure and again turning it back to solid state by decreasing pressure is called resolution. Okay. What is difficult in mountain? Okay. At high altitude, the hill cooking food is difficult. High altitude means lower atmospheric pressure. Boiling point decreases if the pressure is low. So at the top of the hill, cooking takes longer time because due to low pressure, water starts to boil at comparatively lower temperature. As temperature cannot be increased, so it takes longer time to cook. Let's see. Given L1 25 meter, del T 16 degrees Celsius, so we know 16 Kelvin. The change is same. Del L, the maximum issue, 15 centimeter, that means 0.15 meter, sorry, 1.5, so 0.015, my mistake. Alpha is equal to what? See it and try to understand or try to realize how can we do the math. Okay. Well, we have to find alpha. Okay. Now we know alpha is equal to L2 minus L1 by L1 del T. So L2 minus L1 means del L, L1 del T. So 0.015, L1 means 25 and 16. So what we can get from here? 0.015 divided by 25 into 16, 3.75 into 10 to the power minus 5 per Kelvin. It is the answer for C. And the answer for D. Is it possible? But it will remain safe. So here the same issue is given. Most of the given are the same. 25 meter. The del T is changed, like 40 degrees Celsius equal to 40 Kelvin. So please try to remember it very clearly. Okay. And alpha is 3.75 into 10 to the power minus 5. So as we find here from C, and del L is equal to what? Okay, del L prime. So del L prime is equal to alpha L1 del T. This is prime exponent. This is changed, so give the prime side here. Alpha 3.75 into 10 to the power minus 5, L1 25 and 40. What we get from here? Into 25 into 40. So the answer is 0.0375 meter. If we try to do it as a centimeter, so 3.75 centimeter. So from the above mathematical explanation, we clearly see that rising of temperature 40 degrees Celsius the required gap is 3.75 centimeter, but existing gap is 1.5 centimeters. So the rail line will twist and it will no longer be safe train to move. That's how you will finish the answer. Okay, well, that's all for today. Allah Hafiz.